All right, good morning, everyone. Today, we're going to start chapter 13, but before we do that, I want to make sure we can review what we did in chapter 12. Here's one example we did in chapter 12. Solve that one. All right, let's see. So this has fractions and an equal sign. So whenever we have fractions and equal signs, we always have those 5 steps. What's the first step? Find the LCD. What's the LCD? What is the LCD? 6. I know what LCD stands for, but what is the value of it? So what do we do with the LCD? Multiply each term by the LCD. So here's the first term, 2 over 3x minus 1 over 2x negative 1 over 6x minus 2. So I'll put 6 in front of each of these terms. Remember, a term is anything separated by a plus, minus, or equals. Third step. The third step is what our intent is in the first place. Why find the LCD? Why multiply it? What we're trying to do? Reduce to get rid of the fractions. The 3 goes into 6 twice. The 2 goes into 6 3 times. The 6 goes into 6 once, and that's it. So what do we have right now? We have the coefficient times what's inside the parentheses. So we got rid of the fractions, which is our intent. Multiply to get rid of the parentheses. And then solve for your variable. Whenever you have fractions and equal signs, always do that. 2 times 2 is 4, x. Negative times positive is negative. 3 times 1 is 3, x. Positive times negative is negative. 1 times 1 is 1, x. Negative times positive is negative. 6 times 2 is 12. Whenever you get rid of parentheses, always combine like terms. So we have 4x minus 3x, or 4 minus 3 is 1. So we just have x equals negative x minus 12. Now we solve. We have x's on both sides, so which one do we move? No, don't ever say right to the right to the right. Always say the smaller to the larger. I don't care where the smaller is. You were probably taught in high school, always move everything to the left. No, it's wherever the smallest is to the largest. The smallest in this case happens to be on the right, moving to the left. So we have to get rid of the negative x. How? By positive x. X plus x is 2x equals negative 12. The last step, divided by 2. So we have divided by 2 both sides. So x is equal to negative 12 divided by 2 is 6. And yes, I always advise that you check your answer. So let's see why A. We had our original equation was 2 over 3x. X is -6. 1 over 2 times -6. -1 over 6 times -6 minus 2. So I go back to the original equation. Anywhere I see an x, I put a -6. Before you ever multiply fractions, always reduce them first, because each of these sixes are fractions. I know you were taught in high school or junior high, multiply, then simplify. No, that makes it much more difficult. Always reduce first while they're still small. 3 goes into 6 twice. 2 goes into 6 3 times. 6 goes into 6 once. So we have 2 times -2, -3, -1 times -1, minus 2. Here's the equal sign. So positive times negative is negative. 2 times 2 is 4. Negative times negative is positive. 1 times 3 is 3. Negative times negative is positive. 1 times 1 is 1. Minus 2. -4 plus 3. 4 is bigger, so the answer is negative. 4 minus 3 is 1. 1 minus 2. 2 is bigger, so the answer is negative. 2 minus 1 is 1. So -1 equals -1. So that means -6 is our answer. Again, always check your answers before you move on. Let's do one more example, then we'll move on to chapter 3. (0.06 times 100 minus x plus 0.04x equals 0.05 times 92. Decimals are not different than fractions. Because, for example, 0.06 is the same thing as 6 divided by 100. 6 divided by 100. So it means each of these numbers can be written with 100 as a denominator. So this is 6 over 100. 1, 2, so it's 4 over 100. X. Since each of these have 2 decimal places, that means I have on the bottom 2 zeros. You could, yes, exactly. That's it. You do the exactly same thing there. I'm gonna show you how they're related. There's exactly the same thing. Yes, I'm glad you remember that part. Very good. But yeah, since 0.06 is the same thing as 6 divided by 100, because I move it 2 decimal places. Each decimal place is a 0. So what's my LCD? My LCD is 100. So I multiply each term by 100. There are only 3 terms. There's this first equation plus the second equals the third. So the hundreds cancel. So we have 6 times 100 minus x. The 100s cancel. 4 times x. The 100s cancel. So you simply have that. You notice how when we put them in fractions, we found the LCD is 100. We do the same thing here. We would have done the same thing in the first equation, original equation. Since each of these have 2 decimal places, if I multiplied each of these by 100, the same thing would happen. For every 0, I move it a decimal place to the right. 100 is 2 zeros, so I move it 2 decimal places. Either way, you can either convert it to fractions and then reduce, or count the number of decimal places on all of these and see how many zeros you need. Notice, either way, we end up with this easier looking question. So we found the LCD, we multiplied it, we reduced. Now we have to multiply, get rid of the parentheses. 6 times 100 is 600. Positive times negative is negative. 6 times x is 6x plus 4x. Positive, positive, positive. 92 times 5, 460. 92 times 5. 5 times 2 is 10. 9 times 5 is 45, plus 1 is 406. Or 46, 460. Whenever you get rid of parentheses, always combine like terms. 6 is bigger than 4. It's negative, so the answer is negative. 6 minus 4 is 2. Then what? No, minus 600. We're trying to get the x by itself. Since all the x's are on one side, everything that's not on x goes to the other side. So we subtract 600. Negative 2x equals 600 is bigger than 460. It's negative. So 600 minus 460, borrow 1. 10 minus 6 is 4. 5 minus 4 is 1. Is negative 140. I want you all to at least start off doing it by hand. Check your answers with a calculator. If you're not sure about your subtraction, it's not bad, but check it with a calculator to make sure, because I'd hate for you to miss a question because you did one careless error. So please, please, please check your answers with a calculator if you want to. Okay, so I have negative 2x equals negative 140. What do I do next? Never divide by negative 2, by negatives. Never divide by negatives. Just change the signs first. Treat the signs and the numbers separately. More students will make more mistakes if they divide by a negative number, because you'll have negative signs everywhere. So before you divide, change the signs across the entire equation. So now we divide by 2. Remember, from day one, I always said, treat the signs and the numbers separately. No, we have 2x equals positive 140. One more time. That's a very complex question. One more time. Yes.
So I would say we have to do a sum that says 2x, positive 2x equals negative 140. Are we still going to change the sign of negative 140?
No. Well, There's if we had, the only reason we change the sign of is if the X negative is in front of the X. That's the only time you ever change the signs across the board. Now, yes, good question. The only times, because you never, your answer has to be a positive X. So if you have a negative in the coefficient in front of X, then you change across all the signs. That's the only time. Good question. I'm glad you asked that. In other words, if we just had 2X equals negative 140, we wouldn't change anything because it's X is positive. Again, everything depends on what we do with X. That's the only thing we're worried about. Whatever we do to X, we do to the other side. Because that X is our target. So 2 goes into 14 7 times. So the answer is 70. So again, you see that decimals and fractions are treated the same way. All right, so that does it with chapter 12. And we did some word problems. I want you all to do your homework first to see how you're doing with word problems before I do some more examples in class. So I need you all to get to that far before, so you can ask questions if you get stuck somewhere. All right. Chapter 13 deals with graphs of linear equations and inequalities in two variables. This is chapter 13 deals with graphing linear equations and inequalities in two variables. Now, what does that mean? Graphs of linear equations and inequalities in two variables. And functions. So just write, you don't have to write that stuff. Just that's the title. That's the title. The rest of that stuff is our review from chapter 12. All right. What does that mean? When we say interpret graphs, there are predominantly two types of graphs that we always are faced with. Interpreting graphs and charts. When you graduate and get a full-time job at a company, you'll sometimes be asked to present a report of what's going on. In that report, you'll have tables and graphs and charts because a picture is worth 1,000 words. Looking at a graph is more informative to people than looking at a bunch of words and numbers. For example, if I give you this table, on the bottom are the years 2004, 2005, 2006, 2007, 2008, 2009, 2010, and 2011. And vertically, 5,000. 5,500. 6,000. Okay, I'll put zeros in. 6,500. 7,000. 7,500. 8,000. 8,500. You notice what we have here? We have a horizontal plane and a vertical plane. You've seen charts like this before in newspapers, on news stories, on TV even. You'll notice that time is always on the bottom line, always. And whatever you're looking at, whether it's number of people, number of students, number of dollars, number of gallons, or whatever, those units always go on the vertical side. Okay. Let me draw these bar charts here. Yeah, my picture's not that good. With this graph, I'm going to ask you some questions. What year was were the expenses greater than 7,500? In what years, these are the expenses. In what year were this expenses greater than 7,500? Yeah. So in other words, what is higher than this line here? This one, which is at 2008, and that one. So at 2008 and 2009. Second question. Estimate the expense in 2004 and 2008. So in 2004, what do you think it was? What does it look like? Again, it's an estimate, so it's a ballpark. Yeah, because it's bigger than 5,500, less than 6,000. So it almost looks like in the middle. So it's approximately 5,700. How about in 2008? What is it approximately? Oh, look at it. It looks like it's almost exactly between 8,000 and 7,500. So what number is between 8,000 and 7,500? Yeah, approximately 7,700. Because if the graph is looking further to one than the other, then you go up to the higher. So if it's not, if it's in the middle, how about 09? Where's it in 09? Yeah, 8,000. Because it's on that line. So how would you describe the change in the expenses as the years progress? No, not asking you for a specific value, just in your own words. What do you notice about the graph? What is it doing? It's increasing. So what this thing says is the expenses are increasing each year. Again, it's all it's asking for is, what do you notice about the chart? I notice that the expenses are increasing. Does it tell you about anything else? What's causing the increase? No. The cause of the increase could be because of supply shortage, of increased salaries, damages, or whatever. It's just our expenses, whatever the cause. This doesn't tell us that. It just tells us that we spend more each year. So just, yeah, don't ever just interpret or make out. It's just what it says, interpret what's on the graph. So this is called a bar chart or a bar graph. Can you guess why? Because these bars indicate from the year to the expense. Another popular is called a line graph or line chart. These are the years again. $1.75, 2, 2.25, 2.5, 2.75, 3, 3.25, 3.5, 3.75, 4. The difference between this and a bar chart is there's a specific dot. So the first one is 04, then 05, 06, 07, 08. These are the years. Remember, the bottom line is always the time. And so specifically, there are dots above each one of these years. The reason it's called a line graph is because we connect each one with the next by a line. This is, for example, gas prices. Each year, the gas prices, the average gas price rose and rose and rose and dropped, and then rose again. When was there a decrease in price? I'm sorry, I'll let you catch up with this. I'm sorry. It's a lot of stuff on there. So when was there a decrease? There was a decrease between 08 and 09. You can't really say there was a decrease in 09 because that's only 1 year. A decrease happens between 2 years. It starts at 08 and goes down to 09. What's the overall, what's the trend? What do you notice about the graph? Yeah, it's an increasing trend. The trend basically what's saying is as the years progress, the gas prices are getting higher and higher and higher. Estimate the prices of gas in 2004 and 2008. Again, it's an estimate. It doesn't have to be exact. It's just a logical guess to it. What do you notice in 04? Yeah, approximately 1.85. How about in 2008? So it's approximately what? Yeah, it's just under 5. So it's 3.45 or 3. You even say 3.9 even if you wanted to, 3.8. Again, when it says estimate, it's a logical guess for it. But in reality, this is the final product. Where it came from graph the average price of Starbucks coffee per ounce. No, from the data below. Because when you collect data, you have a whole bunch of numbers. What does this first column represent? The year. How about the second column? Yeah, it's the average price per ounce of Starbucks coffee. In other words, in order to get the 1.88, how would you get where did that number come from? Well, what you do is take each year, each month of the year, see what the average price of that coffee was in that month, and then average all 12 of those months. That's the average for that year. And do all of those. And then what would you do with this? The year here and price here. Just plot the dots. Let's say this is 04. It's at 1.8. So this is 1.5, 2.0. So it'd be approximately there. At 05, it's 2.3. So it's between 2.0 and 2.5. So we have that trend. So what you do is in each one of these years, you put a dot approximately where you could on that graph. And then there you have your chart. So that's how you interpret graphs. What's always on the bottom line? Time. Why is time always on the bottom line? Is what? Well, does it ever go backwards? Does it ever stop? No, because time always keeps on going. It doesn't go back, doesn't stop. The data, actual data, it can go up, it can go down, it can disappear, it can be positive, it can be negative. But time can never stop. It always, always, always progresses. So linear equations. In two variables. What does that mean? What's a linear equation? In your own words, what's a linear equation? It's an equation that defines what? I'll give you a clue. Right. It's an equation that defines a line. Okay, we all know what that means. We know what an equation is. What's an equation? Any statement that has an equal sign in it, where one side's equal to the other. What's a line? Yes. No, that's in order to do the work, you have to know the definitions as we go along. And that's why I try to stress, that's why I try to define every time we go along in the notes. And in order to know what the question is asking, you have to know what those words mean. And that's why I try to keep on stressing and stressing and stressing. Mathematics is a language. You have to know the words that are being used to understand what you have to do. So when you see the word line, what is a line? We can draw a picture of it. We use the word all the time, but what does it mean? How would you define a line? No, I think you can't say that. It's something that goes straight. It can also go, it could go down and go backwards. A line can go anywhere. But yeah, we'll get to this. We'll define what a line is as we go through this chapter. All right. An equation of a line. Looks something like this. Actually, because we want two variables, X and a Y. This form is called the standard form of linear equations. AX plus BY equals C. In order to solve it, a solution of a linear equation requires two numbers. An X value and a Y value. In the equation AX plus BY equals C, A, B, and C are integers. They're numbers. They never, once you define A, B, and C, it never changes. They're constant. They stay the same. Once you start, they never change. X and Y are called variables. They're called variables because they change. X is called the independent variable. And Y is called the dependent variable. All right, so X and Y are variables. They change values. As one changes, the other one changes. A solution to a linear equation is called an ordered pair. An ordered pair. It's called an ordered pair because it has to be in a specific order. Whatever the X value is goes first, and whatever the Y values goes second. This is called an ordered pair. It's also called a point. It is a coordinate. It's a location. So ordered pair, point, coordinate, location, they all mean the same thing. Test to see if an ordered pair is a solution to a linear equation. From now on, I'm simply going to call it LEs. Linear equation is LE. Test to see if an ordered pair is a solution to a linear equation. Here's my linear equation. How do I know that's a linear equation? How do you know it's a linear equation? It's an equation. It could be a quadratic, it could be a cubic, it could be a radical, a rational. What's that? Has an X and Y, but more so about the X and Y. What do you notice about the X and Ys? They're ordered that has it has two values, but it means it has a point. More so, we know it's linear because they have no exponents. X is not on the bottom because you could have equations that look like this. That's not a linear equation because X has a square and Y is on a denominator. In other words, X and Y do not have any special operations. Square roots, squares, absolute values. All right. So how do we test? Is 0, 10 a solution? How would we test to see if a value, a specific value, is a solution? Yeah. Substitute the X and Y values into the equation. And check it out. And work it out. Five X plus 2Y equals 20. What is my X value I'm testing? 0, because this is my X value. This is my Y value. So if X is 0 and Y is 10, do both sides equal each other? 5 times 0 is 0. 2 times 10 is 20. 20 plus 0 is 20. So 0, 10 is a solution. Check these points to see which ones are not solutions. We see by checking them out that the first two are not solutions and the third one is. So we are playing X and Y. This is X, Y, X, Y, X, Y. All right. Complete the tables. If I give you this equation, and I give you specific values, how would you test it? What would you do? What is the first one asking you to do? Yeah, we have to figure out what Y is. How do we do that? Yeah, we have the equation. We have the X value, so we plug in the X value. 2 times 5 is 10, minus 9 is 1. So the value for Y is 1. The same thing for the next one. Now this time I plug in a 2, because that's what the X is. 2 times 2 is 4, minus 9. 9's bigger. 9 minus 4 is 5. Now in the third one, I'm given the Y. So Y is 7. I have to solve for X this time. So I add 9 to both sides. 9 plus 7 is 16. Divided by 2. So X equals 8. And likewise, the last one. I'm given the Y value, so I plug in the Y value is negative 13, solve for X. So X equals negative 2. Pretty difficult. It's whatever they give you. If it's the X value, plug in the X, solve for the other one. It can also be given to you in this format. 2x minus 3y equals 12. I can ask you to find the specific values. Complete the ordered pairs. So for the first order pair, what value am I giving to you? Which one? I'm looking at this one. What value is this? That's the X value. So in my equation, anywhere I see an X, I put a 0. And I'm solving for Y. 2 times 0 is 0. Negative 3Y equals 12. Change the signs. 3Y equals negative 12. Divide by 3. 12, it's negative. 12 divided by 3 is 4. So the answer is negative 4. The next one here, I gave you the Y. So put a 0 in place of Y. Negative 3 times 0 is 0. That's gone. Divide by 2. X equals 6. The X is 3. We have to solve for Y. 6 minus 3Y equals 12. Change the signs. And divide by 3. Again, everybody should have no problem. I mean, you should be just not look at my board every 5 seconds. You should be able to work all these out yourself and just check them on my board. Because this is the stuff we've been doing for the last 7 weeks. You really should not have any problem with these parts. But yes, people are looking at the board no matter what. Which is why I ask y'all, put your cell phones away when you're in class. Listen to me 100%. I'm solving for the X. I have the Y. Y is negative 5. 2x negative, negative makes it a positive. 3 times 5 is 15. You shouldn't be bobbleheading. I don't want to see this every 5 seconds. I want you to work it out first. Don't copy my work. I'm not going to be next to you when you do your homework. Don't bobblehead. Again, the only thing you should do is look at my board, my solutions. And that should be it. All right, notice up when we did the complete the table above, we had these values. What do those columns represent? What do they mean? What, give me in one word, what does it mean? What do they represent? Not an equation. We know that if we put this one, it came from this equation. We completed this table from the equation. So what do these represent from this equation? We have an X and a Y. What else has an X and a Y component? These are all points, exactly. So this one is the point 5, 1. This one is the point 2, -5. This one is the point 8, 7. And -2, -13. So whether you have actual points or a created table, they all represent the solutions of an equation represent the points. Okay, so that should help us there. So if y equals 2x minus 5, find y if x equals 0, 2, 3, -4, and -7. All right, so the first one, when x is 0, 2 times 0 is 0, -5 is -5. So the first one is 0, -5. That's that point. Now x is 2. 2 times 2 minus 5. 2 times 2 is 4, -5. 5 is bigger, it's negative. 5 minus 4 is 1. So it's at 2, -1. When x is 3. 2 times 3 minus 5. 2 times 3 is 6, minus 5 is 1. So 3, 1. Then at -4. Positive, negative is negative. 2 times 4 is 8. Minus 5. They're both negative. 8 minus 5 is 13. So at -4, -13. And the last point is at -7. Positive plus negative is negative. 2 times 7 is 14. They're both negative. 14 plus 5 is 19. So what do we do with those? Let's graph them. Plotting points. Commonly, these are called XY charts, but let me walk you through where it came from. In elementary school, you first learned counting 1, 2, 3, 4, and you learned a number line. Then you learned whole numbers, had 0, 1, 2, 3, 4. Then you learned integers, you had positive, negatives, and 0. So originally, we had the x-axis, the horizontal axis. And if you think about it, as humans developed, how did we used to travel? At the beginning, we all traveled by walking, horses, wagons, boats, everything was horizontal. And then all of a sudden, what happened? Then we started going up and down, submarines and airplanes. So going up was positive, going down was negative. Now, the story behind this is interesting. This is actually, instead of an XY chart, it's actually called the Cartesian coordinate system. It's called the Cartesian coordinate system because it was named after a French mathematician named René Descartes. Hence the cart. René Descartes. I don't know if you ever heard the phrase, I think, therefore I am. Cogito ergo sum. He was the one who came up with it. He's a French philosopher mathematician. He was sick one day, lying down in bed. His ceiling was about the same as this, had little squares everywhere. He noticed a spider walking on there. And he goes, I can tell you exactly where that spider is from the corner. I know he's moving this many rows down and then this many columns further. So he developed this system while lying down in bed that I could tell you exactly where any object is on a coordinate system. Then they use it for military, for cannons. You have a battlefield, you have horizontally, you have vertically, length. The place you're going to shoot is over here. So aim your cannons over here. So it all developed, and then we learned how to do it in mathematics. The horizontal axis we call the x-axis, or the abscissa. The vertical axis we call the y-axis, or the ordinate. Ordinate. The word coordinate, that means it has to be something paired up with the ordinate. That's the abscissa. These are the coordinates. So any location can now be plotted. What's that location right there? What's the ordered pair that defines that point? What is it? How are ordered pairs? 1, 2. Because the X goes first. In an ordered pair, X goes first and then Y. How about this one? What's that location? -4, 1, because the X has to go first. How about that one? Yeah, I mean, it's going to be pretty rough. So it's -3, -3. Oh yeah, funny. I know my handwriting is horrible. And this last one. (2, -3). So now we know exactly where, if we're right here in the center, then we can tell exactly where any of these points are from that point. Always go X first and then up or down. Either back, left, or right. And these are all our coordinates. What's the location of this middle point? What is its location? You need an order pair. 0, 0. Because it's 0 in the horizontal line and it's 0 in the vertical line. So 0, 0 is called the origin. That's where every point starts off from. Remember I told you about the military story? Yeah, our cannon's here. So I want the target is at 1, 2. So you aim to the right, one click, and up 2 clicks, and boom, you're gonna shoot there. Or from here, I have to go back to the left 4 units, and up 1. Now you have 4 of these things, right? They're called quadrants. Quadrants are labeled in Roman numerals. 1, 2, 3, 4. Because we only have 4 of them. Here's the first quadrant. Here's the second quadrant. The third quadrant. And the fourth quadrant. Now, is that the way we would arrange them if we were designing this thing today? It's backwards, isn't it? It's, how would you call this order of numbering? Is it clockwise or counterclockwise? No, clockwise, the second hand, if this is a second hand, it moves this way. That way is clockwise. So this one's going backwards. This is counterclockwise, which is backwards what we're used to thinking. But you can remember when this was invented in the 1600s. They didn't really have watches everywhere. So what they did have everywhere were sundials. So your clock started the time the sun rose. Where does the sun rise? East or west? You guessing? Anybody know for sure where the sun rises, east or west? It's east. The sun rises in the east and sets in the west. It starts in the east and goes on this way. And then it keeps on going. So that's the reason it was labeled that way. It starts off here, the sun rises in the east, it goes to the west, it sets. On the other side of the world, it rises and it goes, or it keeps on moving around, so it comes back around to the beginning point. So those are our 4 quadrants. Each quadrant has specific arrangement of the ordered pair. In quadrant 1, what are the signs of the numbers in quadrant 1? Are they positive or negative? Yeah, positive and positive. So they're both positive. In quadrant 2, what do we have? Yeah, we go to the left, negative, and then up, it's positive. In quadrant 3, negative and negative, because we go left and down. And in quadrant 4, positive, negative. Good. So simply by looking at the signs of the numbers, you can tell me which quadrant that number sits in. The number -3, 5. This one goes which direction, left or right? Left, up or down? So left and up is the second quadrant. So if you look at from here, go left and up, I'm in the second quadrant. So horizontally, you go left and right, positive and negative. Vertically, you go up or down, positive and negative. And that tells you what quadrant you're in. So far, so good?
So every time we have the coordinates, and let's say we get like a negative, we get the negative top, is it always gonna be like those, the Roman numerals?
For the quadrants, yes. Quadrants are always Roman numerals. Yeah, it's that was that way in the 1500s, so that way today. Because if we use regular numbers, then we don't know if we're talking about a value of a point, a coefficient, or a quadrant. In section 2. Graphing linear equations in 2 variables. Did anybody not get all the videos and stuff I sent out this past weekend? Because there's some people who were not on Remind who didn't get it. So yeah, so at the end of each week, I'm going to update. I'm going to keep it more current instead of waiting 7 weeks to send out the videos. So at every Thursday or Friday, you'll get a new remind of the new videos and notes. For this class, I have all the homework assignments printed out. I just have to fill them out and then create the videos and I'll upload those. I'm going to work on that ASAP because I want to try to get it done before the end of way before November. Give you a chance to catch up and then look at, if you get stuck someplace, you can just look at the videos. Yes. We're finishing the eighth week today. No, we're on Dmat now. We finished Basm a week and a half ago. And hopefully y'all see the final exam for that one. If not, then I forgot what buttons I have to press to get it up and loaded. So let me know if you're trying to take the final exam for Basm, tell me. But remember, I'll give you 2 tries at the final exams. And if you need more, just ask. I'd rather you ask me for more tries than cheat because you're down to your second try. So if you want to do 5 tries, as long as you don't cheat, I'm happy. On eCampus. On eCampus? Yes, it's where your homework is. It'll be on the very bottom of all the homework assignments. No, it'll be an exam. Yeah, it'll say final. It'll say Basm final exam. Okay, so it may not have popped up, so I will check that. I mean, Blackboard and me have had troubles for a long time, so I will do best I can, which is why I don't put my videos and everything on Blackboard, because sometimes you won't be able to get on it. I send you the links to it, because YouTube's always going to work. Yes. Well, yeah, well, on my math lab, when you go into there, you'll have both the homeworks and the exams on there. And it'll just have the title Basm Final Exam. All right, so graphing linear equations in two variables. AX plus BY equals C. So basically, to graph a linear equation, an LE, you need 2 points. Why do you only need 2 points to draw a linear equation? Yes. Yeah, if you have 2 dots and you connect them with a line, there's your line. And every point will be on that line of that equation. So basically, if I give you an equation, if I give you this equation, x plus 2y equals 7, I could ask you, find these values remember, all these points, all these are points. They're ordered pairs, they're points. They define the line, because once I plug in the x value, I can determine what the y value is. All right, for the first one, is that my x or y? Yeah, because every point has an x component and a y component. So I have -3 plus 2y equals 7. Solve for y. Add 3 to both sides. 2y equals 10. Divide by 2. So it equals 5. So at -3, I have 5. So I put a dot there. At -3, 5. Then I do -1. Two y equals 8. Divided by 2. Y equals 4. So I have my second point at -1, it equals 4. I do 3. When x is 3, y is 2. And when x is 7, y is 0. So work them out. I mean, you see what the points are, work them out, and you have the points. And then hopefully when you graph them, you should fall on the same line approximately. But my graph is horrible, so it didn't fit. Each one of these dots should line on that line because they all come from the same equation. The what? The work? Which one are you stuck with? Okay, you have 5 plus 2y equals 7. What do you do first? You're solving for y, so what do you have to get rid of first? Yeah, because I mean, at this stage of the game, that easy part in the bottom, everybody in here should be proficient with that already. Oh, no. That would mess up, yes. Now, if you notice, I gave you the -3, -1, 3, 5, and 7. But what if I didn't give you those? What if I just gave you the equation? What if I just gave you the equation? I asked you to graph it. How would you do it? Well, since you know you have an x and a y component, you just pick some points. Remember, is this a linear equation or not? Well, don't look at me. Why not? You think it is? Why would you think it is? Are there any exponents? Are there any radicals? Is x on the bottom? No. Since it's just x and y, no powers, no exponents or anything, no special operations, it's a linear equation. Because it's a linear equation, all you need are 2 points. The easiest points to find, if I set x equal to 0 and I set y equal to 0. Why are those the easiest to find? Yeah, if you set them equal to 0, that value disappears. So if I have here 0 plus y equals 6 and x is 0, so what does y equal? 6. If I set y equal to 0, I have x plus 0 equals 6. This is gone, so x is equal to 6. When you set x and y equal to 0, that eliminates that part of the equation. Anything times 0 is 0. So let's look at if we plot these points now. 1, 2, 3, 4, 5, 6. So we have a point at 0, which is here 0, up 6. So we have a point there. And then we have a point at 6, 0. On the x, I go 6 and nowhere. I have 2 points. I connect the dots and I'm done. That's my graph. So to draw a linear equation, you only need 2 points. But the software may ask you for 3 points or 4 points. If that's the case, then just pick some values, 1, 2, and plug them in there. 1 plus y equals 6. Subtract 1, so y is equal to 5. So this is the point 1, 5, which is here. When x is 2, 2 plus y equals 6. Subtract 2, I get y equals 4. So at 2, 4, I got another point. Any questions so far? These first 2 you see here are they're special points. They have a unique name. They're called the intercepts. Intercepts are where the graph crosses the x and y axis. We have 2 of them. The x-intercept and the y-intercept. What do you think the difference is? What is the x-intercept if you put it into words? What is the x-intercept? It's where the line crosses the x-axis. That's the x-intercept. Where do you think the y-intercept is? Yeah. Where the line crosses the y-axis. Let's look at our picture we just did a second ago. What's that one? What's that? Okay, the location of this one is 6, 0. Is it the x or y intercept? It's the x-intercept. So the x-intercept, the location is 6, 0. How about this one? What's that location? Very good. And that's the y-intercept. Everybody okay with that? Now, this is important because how do we find the x-intercept? Here are the steps. To find the x-intercept, what does y have to be? Yeah, in order to find the x-intercept, there can't be a y value. So set y equal to 0. And then solve for x. And there's your x-intercept. That it's that coordinate. The y value is always 0 in the x-intercept. How do you find the y-intercept? Steps here. What's the x coordinate? Yeah, so to find the y-intercept, you set x equal to 0. Get rid of the x. And then solve for y. And that's always going to be the y-intercept right there. If it works, it's a great way of doing it. In other words, if it works, if you always end up with, if you have a solid number, if you have a fraction, don't use this method. Use another value. But if this thing works out like it did here in this earlier problem, we got 0, 6, 6, 0, it's perfect. Here's some examples of the intercepts. Graph 2x plus y equals 4. What form is that equation in? X and y on the same side, right? That's called the standard form. If x and y are on the same side and it equals something, 0, positive or negative, it's called the standard form of a linear equation. So let's use the intercept method. Let's graph this one. What's the x-intercept? How do you find it? How do you find the x-intercept? Look at your notes if you don't remember. We just put up there 5 seconds ago. Y has to be 0. So in other words, basically what this says, set y equal to 0. In other words, just erase the y. So we have 2x equals 4. Divide both sides by 2, so x equals 2. So the x-intercept is at 2, 0. So what's the y-intercept? How do you find it? What do you do? Set x equal to 0. In other words, it disappears. So y equals 4. And there's your graph. So to find the x-intercept, just erase whatever the y is. Only keep the x there and solve it. To solve the y-intercept, get rid of the x. Only keep the y. Solve this one using the intercept method. Actually, would you be able to use the intercept method here? What you have to look at are these coefficients multiples of the answer of the constant. Only if that happens, only if that's if both of them are multiples of the answer, then you can use the intercept method. In other words, if that was 5x plus 2y equals 6, 2 fits into 6, but does 5 fit into 6? No. So you couldn't use the intercept method. Or you could for y, but that only leaves you 1 point. So what are my x-intercepts and y-intercepts? Don't bobblehead. Work it out first and then check, because you have to test your abilities here, not my abilities. So you'd plot those 2 points at 2, 0, 5, connect the dots, and there's a graph. Graph that line. Use the intercept method here. How do you find the x-intercept? Set y equal to 0. We have an equal sign of fractions, so let's get rid of the fractions. Since the LCD is 3, multiply each term by 3. Three times 0 is 0. The 3's cancel, so we have 2x. 2 times 3 is 6. Add 6 to both sides. So 2x is equal to 6, divide by 2, x equals 3. So my x-intercept is at 3, 0. What's my y-intercept? Look at your notes. What does it say to find the y-intercept? What do you have to do? Yeah, set x equal to 0. In other words, just erase the x's, it's gone. So y is equal to, yeah, so it's 0, -2. And there's a graph. Is everybody kind of okay with that? Again, you have your notes. Horizontal, intercept method for the x-intercept, erase the y's, solve for x. The y-intercept, erase the x's. All right, we have 2 more types of lines to talk about. Oh yeah, also. What form is that? Standard. And we just saw another one that looks like this. The last equation we solved. Yeah. The last equation we solved looked like this. Y equals 2/3 x minus 2. This form of equation has another name. When you have y equals whatever's in front of the x plus or minus some number, that's called the slope-intercept form. Even though next class we're going to talk about the slope, but I'm giving you a heads up. This number here is the y-intercept. This number here is called the slope. And the slope is defined as rise over run, vertical shift over horizontal shift. This method is, if it's in this form, it's a lot easier to graph. Because remember, if we had it in this form, we have to plug x and y in there, work it out. But if it's in this form, the first thing you do, plot the y-intercept. The y-intercept is what? -2. So then you look at the slope. The top number says either go up or down. If it's positive, it goes up. If it's negative, it goes down. So where do we go from this point? Up or down? How many spaces? 2. So we go 1, 2. And the bottom number is left and right. It always goes to the right. So we go up 2 and over 3. Which is exactly what our graph was. So when we get to it, when we start doing equations, the slope-intercept form is a lifesaver. It's much easier to deal with that. Because there are 3 forms of equations, and when we get to it, I'll show you the last one next time. The last thing I want to talk about are horizontals and vertical lines. That, not that. Oh well. So when I talk about a horizontal line, what does a horizontal line look like? Yeah, left and right. It goes something like this. Does it ever cross the x-axis? The x-axis is here. Does a horizontal line ever cross the x-axis? No. Let's talk about horizontal lines. 1, they never cross the x-axis. Why is that important? Because if it never crosses the x-axis, then there is no x value in the equation. Since it never crosses the x, you can only have the variable in your equation if it crosses that axis. Since there's no x-intercept that doesn't cross the x-axis, there cannot be an x value in the equation. So the equation looks like this. Y equals some number. And whatever that number is, that's your y-intercept. So if you have a horizontal line, it's wherever that line crosses the y-axis, that's your equation. Yes. What's that? Yes. Horizontal lines. So far, we haven't talked about horizontal lines yet. If we have an equation that has an x and a y value in it, if it has an x and a y value, then that graph has to cross both x and y axis. If there's no x value in it, then it cannot cross the x-axis because x cannot equal a value. So that's why if you see an equation that looks like y equals, let's say y equals 3. We know since there's no x value in there, it's a horizontal line. It crosses at 3. It's a horizontal line crossing at 3. Vertical lines. Vertical lines look like this. It goes up and down. crossing through, crosses the x-axis at some value, some number. Never crosses the y-axis. So there is no y value in the equation. And the equation looks like x equals whatever number we're dealing with. Does that make sense? So if it has an x equals some number, then plot that number there, and it has to go up and down, because it cannot cross the y-axis. If it's y equals a number, plot a dot at that number, and it has to only cross through that one. That's it. And in the next class, we're going to discuss slopes, horizontal lines. The slope of this line is 0. The slope of the horizontal line is 0. The slope of a vertical line is undefined. And it all has to do with the equation that we define as the slope. So graph this line. Graph that line. Shouldn't take much time at all. It's only 2 steps. Is it a horizontal or vertical line? Horizontal. What do I have to do first? Subtract 2, because I have to get the y by itself. So there's my graph. That's my graph. It's a horizontal line crossing at 1. How about that one? Again, what do you notice about that equation? What's missing? The y value. So it can never cross the y-axis. That means it can only cross the x-axis, and therefore it's a what kind of line? It's a vertical line. So what do I do first? Subtract 5 from both sides. So the positive negative 5 cancel, so 2x. They're both negatives. 5 plus 3 is 8. 2 times x, so we divide by 2 both sides. 8 divided by 2 is 4. So there's my equation. So my graph crosses through -4. And since it's x, it's vertical. What's the slope of that line? Undefined, very good. The slope is undefined. Again, next class, we'll talk about why it's undefined. We're going to finish up chapter 13 next time. Because fortunately for us, 13 and 14 only has 4 sections in it each. So we'll finish those up pretty quick. And then the last 2 chapters, we have 7 weeks to do. We have plenty of times. So after we finish everything, and I'll be here, whoever wants to ask questions. All right. So that's it for today. Thank you for your time. Not many people play with their phones today. Yay.